All right. Okay, so I have 235. I'm going to get started. This is COMP2404, Introduction to Software Engineering, and I'm the instructor, Gerald Hill. Just looking for my pen. So we're on, this is just after the midterm. So I think the marking deadline for the midterm is around sometime this week, 14th to the 16th, in that area. Of course, the TAs have to mark your assignment too first. But yeah, so we're here on the 6th. It says design patterns, but we're actually going to finish off inheritance today and start talking about polymorphism. Basically, at this point, we've got a good solid technical base. So now we're going to look at more abstraction layers. So just ways to make our code easier to modify, make algorithms easier to write, and make it so that when I make changes, they're only done locally. And all of that depends on inheritance and more specifically polymorphism. But yeah, so there is a tutorial. Tutorials resume this week. There's a tutorial due on Saturday, and then tutorial 7 has also been released, I believe. If you don't see it, let me know. So those two are out. But yeah, that's the schedule. Any questions before we get started? Okay. So we were talking about inheritance last class. We had just gotten to multiple inheritance. So in Java and in most other programming languages, there is not multiple inheritance because it's complicated. Right? So C++ has a bunch of legacy stuff that, because it was written so long ago, they made the best design decisions they could, and then they had to be backwards compatible. So we're kind of, I don't want to say stuck with all of this stuff, but certainly new languages tend to go the way of Java, which is they don't have multiple inheritance. But so in C++, if we want to have something that is a house and is a vehicle, for example, then we want to inherit from both of these base classes. So in Java, you use interfaces instead, right? And I think most new languages use interfaces. They're a lot easier and a lot less error prone. But in C++, we can inherit from two different classes. And what happens is that if I might inherit from two classes. Let's say I'm a grad student and I want to inherit from student and employee. These are both classes in, Carleton University, but both of these inherit from person. They both inherit from the same person base class. So I get what's called the problem is called the diamond hierarchy, right? So this is one version of the diamond hierarchy here. This is the first one we'll do. So what this means is that, well, my grad student inherits from student, and student inherits from person, and I get this name variable from person in my grad student. That's fine. But he also inherits from employee. Employee inherits from person as well. So I'm going to have basically two names. Now, in this example, that seems sort of maybe not what we would want to have happen. But there might be other examples where it's exactly what we want, right? We do want two distinct base classes called person, and we want to have two different names. That could be the case, but maybe not in this case. The other way we can do these things, so again, C++ gives you maximum freedom, maximum flexibility. So that's one way you can do it. The other way we can do it is to specify and tell the compiler, look, there's going to be two of these base classes called person, but they're the same class. So please make sure that I only have one name for my grad student. Right, so this is known as the diamond hierarchy. And this is where, where virtual inheritance comes in. So the virtual keyword gets thrown around. Well, we use it for a few different things. We use it for polymorphism, but we also use it for inheritance. But it's basically designed in inheritance to solve this one problem, this diamond hierarchy. So yeah, let's take a look at that example. or yeah. So what we're going to have here is we're going to have an animal as a base class. And then we will have a human that inherits from animal. And we will also have a horse that inherits from animal. And up until this point, we've seen inheritance hierarchies that look like this. But now we want to make a centaur, right? So a centaur is this half man, half horse type thing. So I want to inherit from both human and horse. And then we're going to see basically how this diamond hierarchy plays out and the solutions or the types of things we can do in order to get what we want from this inheritance tree. Okay, so here we have our animal class, and it has a constructor that says I'm in the animal constructor, and it has a public name variable. So we're going to keep it public just for convenience. And now I want to make a human. Okay, so my human is going to take of course, a name variable because I still need to initialize this animal base class, but it's also going to have an int called num hands. And then we will add a private member variable. Or maybe num arms is the, yeah. So a human being has a number of arms that we can initialize. Mostly 2, but okay, so then in my constructor, yeah, so this name variable is public, but this is still bad form. So I could initialize it this way because it is public, or if it was protected, but we don't want to do that even if we can, right? We want to call on the animal constructor itself and pass in that variable n. Okay, yes. What did I do? Class human, I forgot to make it a subclass of animal. Okay, so now I call that animal constructor and yeah, sorry, it was looking at this one. In human constructor. And I also want to initialize my number of arms variable. So I'll just put using the member initializer syntax. And there we go. I have a human class yeah, as a subclass of animal. And then I also want to have a horse. Okay, the horse is going to be very similar, except it's going to have a number of legs, right? So, and typically they would have 4 legs. So, yeah, humans have arms, horses have legs. Together we have a centaur. It looks like it's highlighting the whole thing, but it's not. Okay, and this becomes, and this also becomes num legs. All right, so now we have the beginning of our class hierarchy. We have the animal base class, and we have the human and the horse as derived classes. So we can do things like human Bob. Bob's got 2 arms. And we can have a horse, I don't even know, Stan. And the horse has 4 legs. All right, and then we can just print out human named Bob.name. And then a horse named Stan.name. Okay. CD. Yeah, sorry, CDP5. Okay, and we're in shared, so we'll run shared. All right, so in the, yeah, we make a human animal, so we call both the animal and the human constructor. Yeah, this should read horse. Okay, so horse constructor Stan, and then we have a human named Bob and a horse named Stan. Everything's great so far, but now we're going to add the little twist, which is we're going to add a class Centaur. Oops, if I could spell. And I'm going to inherit from human and also from horse. Okay, and we will have and then so a centaur has a name, it has a number of arms and a number of legs. See, I'm getting confused with my Java days. All right, and then in Centaur, I will, well, I'm going to use the human constructor to initialize the human part and the horse constructor to initialize the horse part. So I will say human and num arms and horse, the name and num legs. Okay. All right, so a very simple Centaur class. All it does is initialize all the member variables it has. And now I can make a Centaur here named Steve. And he's got 2 arms and 4 legs. Centaur named. Okay, so, and here's where I run into problems. It now says this name variable is ambiguous. Okay, because, well, what did I do here? I just did a very straightforward inheritance. I publicly inherited from both human and horse. Human and horse both publicly inherit from animal. So if I look at my inheritance hierarchy, it doesn't look like this. It has 2 separate animal classes, right? And 2 separate names at this point. So my horse part has a name and my human part has a name, and maybe that's what I want and maybe not. But what's going to happen in terms of my my compiler is going to complain that it does not know which name I'm referring to. So I can say, well, I can give them a human name, or I can write out their human name, Centaur's human name and the horse name. Right, so we use the scope resolution operator, and let's just get rid of these guys for now. In order to specify which of these I want to use. Okay, so you'll notice I'm only making a single Centaur at this point. This Centaur has a horse part and a human part. When I call on the horse constructor, you can see that the animal constructor also gets called. And when I call on the human constructor, we can see that the animal constructor also gets called. So I have two separate animal parts, and both of them have individual constructors being called. As well as I have to specify which name now. And let's say, maybe I want to do Steve dot Ed the horse. That's a good horse name. All right, so now I'm going to assign Steve's horse part to have the name Ed. And now when I recompile and print out the name, well, Steve has two names. The human part is named Steve and the horse part is named Ed. So yeah, that is multiple inheritance with the same base class, but you know, it appears twice in our inheritance hierarchy. So yeah, questions? Okay, so that is maybe not what we want. As we talked about, it might make more sense to have a single name because a centaur is a single beast. It just happens to look like two different things. So we want to inherit an inheritance hierarchy that's going to look a little closer to this. And again, this is now a very specific, this is basically a C++ problem, and it has a C++ solution. That solution being virtual inheritance. So what I want to do is I want to say when my human inherits, so let's go back here. When my human inherits from animal, I want to say, look, this might be shared somewhere down the line. So I'm going to say, I'm going to put a special note here saying that this should not be a separate class. If I happen to have an animal somewhere else in the class hierarchy, it should be the same base class. And I do that using the virtual keyword. So I'm going to say here, I want to virtually inherit from animal. So that means in some sense, it's what's happening further up in my class hierarchy is transparent to the compiler. The compiler can go take a look. And if I have multiple inheritance down the tree, it can say, well, this human or this animal base class should only appear once. Of course, we have a problem here because nothing's ever that simple. So I'm also going to do the same thing for my horse class. I'm going to say, well, I also want the compiler to look back up in the class hierarchy and make sure that if I share this, animal base class with somebody else, that there's only one version of it. So when I do that with both the horse and the human, then my centaur should have a single base class, but it's going to yell at me over this. So let's bring this down where we can see it. So now it's not happy with my my centaur constructor, right? So I've called the human and I've called the horse, right? But what the compiler doesn't know is that, so when I call human constructor, it goes into the human constructor and it calls the animal constructor and supplies that name. And then when I go into the horse, it does the same thing and it calls the animal constructor again, but I only have a single animal base class. So I'm calling the constructor twice. The compiler doesn't like that. So what it's going to do is it's not actually going to call this constructor here. I'm going to have to call it deliberately here. So I will have to say, if I'm using virtual inheritance in this diamond hierarchy thing, I have to call the base class constructor. All right, I have no choice. Or if I have a default base class constructor, then that will get called for you if I don't specify it. Yeah. If they have member functions, yeah. So yeah, that's the other issue. If they did have member functions, again, if I have the separate base classes, then I have to use the scope resolution operator. If I have the same base class, then I don't, but virtual functions are something completely different, actually. So yeah, C++ has a lot of keywords that do a lot of overtime. So yeah, if I make a virtual function, it means something different. Yeah, other questions? Yeah. Well, we had two distinct, so we had two name variables basically, right? And I only wanted my centaur as a single animal. It should only have one name. So it's not that this is right or wrong, but depending on the problem I want to solve, maybe I don't want to duplicate. So it's in this case, I only have a name in my animal base class, but I could have a bunch of stuff. I could have tons, and I'm wasting memory for one. But the other thing is, if I only have one name, then I could change one, and then the other one's still the old one. And yeah, it's. Oh yeah, yeah. We did that earlier, actually. Oh yeah, sorry. Maybe you missed it, but yeah. Let's see if I. So yeah, here, this is just a single animal. And I called the animal constructor and the human, when I called the human constructor, I also called the animal constructor, and the same with the horse. And then I changed the horse name to Ed and then printed them both out. So yeah, I have two distinct name variables in this case. All right, other questions? Yeah. The constructor here. Yeah, so this doesn't get called. So it's the compiler is doing extra duty here. So I can leave that in there, but the only time this is called, as we'll see when we run it, is here. Yeah, because yeah, it is possible that I'm using this horse class, but I'm not. But it's not in a diamond hierarchy, so I still need that constructor call there. But yeah, the compiler handles all that for us. Other questions? Okay, let's see if we can. What did we do now? So yeah, okay, everything stopped complaining. Let's just run this code now. So I'm doing the same thing. I'm making a centaur. I'm going to leave these scope resolution operators here. They still work, but yeah, they should be referring to the same name now instead of two different ones. Okay, so when I made my centaur, I now have only one call to the base class constructor, the animal constructor, and then one call to the human, one call to the horse. When I change the horse's name to Ed, I print out the human name and the horse name, and now both of them are Ed. So now I have only a single base class because I applied the virtual keyword to both the human and the horse. Right, so I needed both here and here. And again, neither is right or wrong, but it depends on what problem you want to solve. All right. So what else? I have to call this explicitly. Oh yeah. Well, I mean, I did use the scope resolution operator, but I don't need it. Or I could, use the animal scope resolution operator. All of this will result in the same thing. But now that the name variable is distinct, I don't have to use the scope resolution operator to reference it. So yeah, this still works regardless of how I refer to the name. All right. So yeah, I think that's about it for inheritance. Questions? Yeah. I left it public just for this demonstration. Yeah, just to make things easier. But yeah. All right, other questions? Okay. Yeah, so if you have two of the same member variables, you use the scope resolution operator. That also applies to member functions, right? If I had a member function in my animal base class, if I use the multiple inheritance, so multiple inheritance is where we have the multiple base classes, even though they're the same class, and shared inheritance is where we have the same base class, but through different channels. So If we have two of the same member variables or member functions and we're using multiple inheritance, we have to use the scope resolution operator. But if we use the virtual keyword and use shared inheritance, then now I don't have to specify using the scope resolution operator. However, I have to call that constructor explicitly. And this is a very, very simple version of the diamond hierarchy, but I could have had, I could have had my tree arbitrarily large, and I have to, everybody I virtually inherit from, I have to call their constructor. All right, so this, this is a very simple version of the problem, and this is probably as far as we're going to get in this class in terms of, well, I'm going to ask you to do this on assignment 4, but it can be an arbitrarily large problem. Okay. Okay. All right, so that brings us to polymorphism. I've switched things around a little bit. So I pushed design patterns back because polymorphism is basically, it's a useful tool. We need inheritance for polymorphism, so it follows from that. And we need polymorphism to implement design patterns, or most design patterns. So we're going to talk a little bit about polymorphism. It's pretty simple what's happening. I'll explain it to you. And but yeah, so we're going to look at, well, first we'll have an overview, and then we'll look at pointers and the class hierarchy and static binding. So in C++, using inheritance, you can have static or dynamic binding. Again, it's that philosophy of they try and give you as much freedom to do whatever you like. But yeah, so of course the effects are a little bit different. Once I use dynamic binding, I can have abstract classes, right? So I can declare a virtual function, and then I can declare a pure virtual function. And a pure virtual function is abstract. It means there's no implementation. So we'll take a look at what that looks like in C++. And then, since we're talking about polymorphism, which is basically, I'm going to use the same function call, but it's going to have different implementations. We're going to talk about one way to do that, which is dynamic casting, which is bad, right? So, but we'll talk about it when we get there. Basically, it makes your code brittle, whereas polymorphism makes your code robust. And then after that, we will start looking at, well, actually in here, we will have a little example of polymorphism, and then we'll get to design patterns and look at some more examples. Okay, so what is polymorphism? Well, poly means many and morph means shape. So essentially, I'm having different behavior from the same function call, right? So I have different objects, but they're in the same class hierarchy, right? So they're related by a base class. And that base class can define a function that I can override in the derived class and give it a different behavior or a specialized behavior. So an example is if you're making a video game and you have a bunch of game objects on the screen. When you call update, of course, their positions all update, but how they update depends on the game object, right? So I have the player that I'm controlling. When I call update, it takes input from my controller and figures out where it should be, whereas the enemy players use some sort of AI, right? So same function call, same update, and same base class of game object, but how they're implemented is different. All right, so polymorphism is a construct for making programming easier. And again, it's sort of at the root of things like design patterns, right? But when you get right down to it, it's really just a compiler trick. It's a table lookup at runtime. The trick is that I have a function signature that I abide by. So when I write a piece of code, I call that function. It's always going to compile, even when I have different derived classes, because the function signature is the same. But the implementation might do something different. But really what's happening is that, when I assign a base class pointer to a derived class, it makes a little table. And that table has the addresses of all the functions and which one the compiler should be calling. So it's an abstraction layer. And in this part of the course, we're getting deeper and deeper into abstraction layers, right? So design patterns and all these things are, they are higher level sort of software engineering ideas at this point. So this is an abstraction layer, and this is sort of the fundamental abstraction layer. So we call a similar functions shared between related classes, and the compiler decides at runtime which function to call. So so I've already talked about this. It's implemented differently, slightly differently in different languages. So, I mean, in Java, I keep going back to Java, but Java, you can use inheritance or interfaces for polymorphism. With C++, we strictly use inheritance. So we have a base class handle, and by handle, I mean a pointer or reference. So maybe I missed the definition, or maybe it's coming up, but when I talk about a handle to an object, I'm talking about the variable that refers to it. So it can be the variable itself, it can be a pointer, it can be a reference. It's just some way that I access this object. So in C++, when I use multiple inheritance, now I can basically have many hats that I can wear, right? So our centaur could, let's say, gallop like a horse, but it could also, I don't know, do sign language, sure. Right, so it has human behaviors and horse behaviors, and I can sort of use it in either instance. I can use the centaur as a human or a horse. All right, so another example is if I have an animal base class and that animal can speak or make some sort of noise, but if I have a cat that's a derived class and the cat says meow, the dog will say woof, right? So we have the same function call, but we have slightly different behavior. Okay. All right, so yes. So what does polymorphism give us? It allows each class in a hierarchy to implement its own behavior. So I can do specialized, classes, specialized speak function. It allows me to add new derived classes, right? So I can add new behavior to my program without affecting anything else, ideally, as long as you program it correctly. So client classes, when I refer to client classes, I'm referring to a class that's using polymorphism. Essentially, so it could be any class. We'll see some examples. But the client class does not need to know what the derived class is, right? So this is not, again, we need encapsulation, so we do not want too many details exposed. So we just need a function and a table lookup, and that's it. So if I have to cast, that's not polymorphism. If I'm casting, I know what the derived class is, right? Polymorphism, I don't know. I just have a handle and I call on that abstract interface. All right, and polymorphism allows us to write general algorithms. So I write something that applies to all animals generally, and then when I make a new animal and add it to my list of animals, then I implement the behavior in that animal class. I don't have to change any of my code other than that. Okay, so yeah, here's the definition of a handle. An identifier used to access an object, so it can be a variable, a reference, or a pointer, as I mentioned earlier. Okay, yes, so in C++, the client classes using polymorphism call a function on a base class handle. And if the handle points to the derived class, and the derived class is overridden that function, then the compiler has to make a decision. So if I'm using polymorphism, then we're using what's called dynamic binding. Dynamic meaning basically, when I call a function, it could be this function, or it's whatever the underlying class's function is. All right, core algorithm stays the same. This is all basically repetitive. Yeah, so in C++, we must use inheritance as mentioned. So we can have inheritance without polymorphism. I mean, we've seen a bunch of examples at this point, but if we want to use polymorphism, we need inheritance. So there must be an is-a relationship between the handle and the derived class that the handle is pointing to. Yeah. All right. So yeah, this is not calling overridden functions using the scope resolution operator. This is something completely different, as we will see. So normal inheritance in C++, as I mentioned, so in polymorphism, we use dynamic binding, but if I just use plain old vanilla inheritance in C++, I use static binding. It's not to characterize it as inheritance is wrong. Static binding is basically I tell the compiler, or I don't tell the compiler anything. I just use regular inheritance, and then it will statically bind the functions, which means that if I call a function with a certain handle, it calls the function of that handle, not the function of the underlying object, right? So if I did something like this, I make a new chicken class, and then I call chicken.speak, and the chicken goes cluck, cluck. And then I take an animal pointer. Since a chicken is an animal, I can point that pointer to the chicken, and then I can call speak, but this is going to call animal speak, not chicken speak, which is, this is the default behavior. This is not right or wrong. The same with multiple inheritance. We just get to decide how this works. So let's take a look at this example of a static binding. No, not this one. All right, so I have an animal class, and the animal can speak, and it just speaks generically, right? It just says something, I don't know. And then I have some derived classes where I specify, specialize, I mean. So my cat will say meow if I call speak. My bird will say tweet. The chicken will say cluck, cluck. And these are all, well, these are derived classes of animals, and the chicken is a derived class of bird. So I specialized even more in my chicken class. So if I look at, yes, this might be helpful. But if I look at my class hierarchy, it goes something like this. I have the animal base class, and then I have a bird as a derived class. And I also have a cat. And then I have a chicken, which is a derived class of bird. And this is the class hierarchy, and I think I have a name. That's a string. And then I have a speak function. That's void. So it looks something like this. And I could, if I wanted to repeat the speak function in these base class or these derived classes, I can. For your assignment 3, when you make a UML, you can or not. It's up to you. Again, it depends on which specification of UML you're using, whether or not you do that. But more importantly, it would depend on, I would put the speak function in one of these derived classes if it was communicating something, if putting it there actually communicated something important. So there's not really a right or wrong here, but yeah. All right, so this is our class hierarchy that we're implementing in this example. So yeah, everything speaks, and then I make an animal, a bird, a chicken, a cat, and then they all talk. Let's see here. Okay. Okay, so my animals that I made, my animal owl speaks, the bird tweets, chicken little red hen clucks, and then the cat meows. Okay, so Nothing spectacular, but at least things are working. So now we're going to take some handles, some other handles. So Al, Tweety handles, but now I'm going to make new handles and I'm going to point them to these different animals. So here I have my animal pointer and I'm going to point that to my Tweety bird, right? And I use the address of operator here because this is a pointer. And once I do that, I can call speak on my animal pointer. Okay, so a base pointer, yeah, that's to derived object. We'll do that. We'll do the other one later. So base pointer to a derived object, and now my bird, instead of tweeting like a bird, is speaking like an animal, right? So this is called static binding. It means the compiler simply looks at the type of handle, either a pointer, reference, or the variable itself, and then calls, in this case, it's an animal pointer, so it calls animal speak. Yeah. All right. Questions so far? Okay. So I can do some, yeah. Well, let's look at some other examples. So this is a bird pointer now that points to Tweety bird, and a chicken pointer here that points to the red hen. So these should call the proper speak function for the handle, which happens to be the same as the derived class. So when I have derived pointer points to derived object, my bird tweets like it should, and the hen clucks like it should. If I do let's do a base class to a base. Who's this, Al? Yeah, so I mean, this should not be any surprise, but just in the interest of thoroughness. So yeah, if I have a base class pointer to a base class object, then it just acts like a base class. I can do bird pointer to my red hen. So this is, let's say, bird pointing at a chicken, right? So it's not just the animal base class, but anywhere up the hierarchy, I can do this little trick. So my bird pointing at the chicken, and now my little red hen is called a bird and tweets like a bird instead of clucking like a chicken. So yeah, this is known as static binding. Really nothing is happening here other than exactly what you would expect, I suppose. So it's not just pointers. I can use a reference. So now I'm taking an animal reference, which we took a little while ago. We don't use them very much except for passing parameters, but I can declare them right in the middle of my function and assign them to something. So in this case, I'm assigning red hen to an animal reference, and then I will have that animal speak. Right, so now it's treating little red hen like an animal through the reference. So reference and pointers, if I'm using static binding, it looks at the type of the handle and not the type of the underlying object. Okay. All right, so yeah, questions? Okay. So now we will get to, well, the interesting stuff, which is, oh yeah, well, all right. So let's look at, this is for static binding. Oh yeah, I have static binding here. So base class pointer to a base class object, I get a base class function call. Base class pointer to a derived class object, I still get a base class function call. Derived class pointer to a base class object, I get an error, of course. I can't point a bird pointer at an animal base class or an animal object. And then derived class pointer to derived class object, I get a derived call. Right, okay. So now we want to do something more interesting. That's static binding. We want dynamic binding. We want the compiler to be smart. If I use an animal pointer, it's going to check the underlying object, or actually, it's just going to check it's a little table that's stored with the pointer. And then it's going to call the correct function based on that underlying object. So this is known as dynamic binding, and we have to basically turn on dynamic binding in order to use it. So how do we turn it on? All right, so we have the same class hierarchy here. Oh, wait. Am I in the right thing? Yeah, maybe I didn't update it properly. All right, let's go back to here. So we'll start here, and we're going to, now we want to use polymorphism and dynamic binding. So what we're going to do is we're going to add a flag to the compiler to tell it this is a virtual function now. So I add the virtual keyword at the base class. Okay, so this is my base class speak function, and I'm going to add it there, and it's going to propagate all the way down the tree. Right, so it's going to go to cat, it's going to go to bird, and it's going to go to chicken. So now when I have an animal pointer, let's base class to derived. Who did we have there before? Chicken. Oh, it's red hen, sorry. So now I have an animal pointer pointing to a chicken object. It's going 2 steps down the class hierarchy. And yeah, I have a bunch of, well, let's take a look at what happens. All right, so animal Al speaks, Tweety, yeah, that's, so base class pointer to derived class, and my little red hen, is identified as a chicken and clucks like a chicken, even though this is a pointer pointing to it. The next one, I have a bird point. Yeah, these are bird pointer to a bird and a chicken pointer to a chicken. I have a bird pointing at a chicken, a bird pointer pointing, and red hen still clucks. Okay, so I've only added the virtual keyword at the very, very base class, and it is propagated all the way down the tree. So anytime I override this function, this speak function, it becomes virtual in any of the derived classes. All right, however, this is enough to get it to work. But the convention is that we add it all the way down the tree, right? So this is, well, it's conventions, it's hard to shake them sometimes, but the other thing is that it makes your code more self-documenting. If I mention that this is virtual, then whoever's using my class then might, take a look at the base class to see if that is also virtual, right? So I'm communicating something to whoever's using my class that, hey, this is not just static binding, or, at least not at this point in the class hierarchy. Yeah. So it doesn't make a difference in terms of the function. Everything will still work the same. But in terms of, for whoever's using your class, they have that extra information now. So yeah, I still have base class pointing to derived class, the chicken clucks. Yeah. All right, questions? Yep. Yeah, let's try that out. So that means, yeah, get rid of this. Actually, that should be fine. So yeah, I've got rid of it in animal. Now, so yeah, at the animal level, my animal handle now is using static binding. So, but from bird, well, bird and cat. So I left it in bird and I left it in cat. So those are now, from there on, it's virtual. And I think I did. Yeah, so I have a bird pointer to red hen. So bird pointing at a chicken. And then, yeah, the chicken is still treated like a chicken. So yeah, you can turn it on basically anywhere in the hierarchy, but once you do, it's there for good. All right, other questions? Yeah. Make the, I would have to look that up. I think you have to choose which functions to make virtual. There might, I'm not, off the top of my head, I'm not aware of any way to do that, but maybe there is, I don't know. Plus there's, so many versions of C++ could be out there, yeah. No, it definitely has to go in the base class, right? So if I'm, for instance, so what I want to do here is I want to have all of these pointed at by, let's say, an array of animal pointers. And then I'm going to call speak on each of them. And if I do that, I need the virtual keyword in the animal class. That's the only place where it really matters. The rest is just for communication purposes. Yeah, other questions? Okay. All right, so that is, dynamic binding. And so in C++, when we call a function, we have two types of binding: static binding, which is the default, and dynamic binding, which we turn on by using the virtual keyword in the base class. And then it goes all the way down the tree. And yeah, what happens behind the scenes? This is the one thing I don't really like about C++. It's a systems level language, but because it's object oriented, it hides certain implementation details, right? Like, well, what happens in dynamic binding? I mean, we talk about it and you learn it, and it's important to learn it if you want to write. I mean, if you're writing real-time code, then every kind of CPU cycle could matter. So yeah, we take this, but the implementation is hidden here. But there is actually, when I make a point using dynamic binding, there's a table associated with that pointer, and there's an extra lookup. So it's a tiny bit slower than static binding, but not terrible in most cases. All right, yeah. What is function binding? Selecting the correct function to execute. So it can either happen at compile time or at runtime. Yeah, and we've talked about static binding. This is made at compile time, always called on the variable type, not the object type. And we can use it with pointers as long as the functions are non-virtual. Dynamic binding, the selection is made at runtime using the table lookup. And we can implement it using pointers and virtual functions or references and virtual functions. Oh yeah, that was the other thing. Yeah, so we did have so I did show you the reference. All right, so it does work for both references and pointers. Okay, so a virtual function, yeah. So it's a function selected for execution at runtime. Again, all it means in practice is that my pointer has a little table beside it or with it. So in Java, everything is virtual by default, right? So it looks at the underlying object and makes a call based on that. But in C++, we can choose, although virtual is more useful, generally speaking. The virtualness is inherited all the way down the tree from the base class. And however, by convention, we want to repeat this keyword on all the derived classes just to keep, whoever's using our classes informed of what's going on. All right, so we've seen virtual functions, but we can also have virtual destructors, which should not be a surprise because, destructors are simply another function. So if we make a virtual destructor, then we call the correct destructor based on the underlying type, and if we have a non-virtual destructor, and let's say I have a bird class and I'm pointing at it with an animal pointer and I call delete, Well, what happens is it calls the destructor based on the type of handle, and it's going to call the animal destructor. All right, so if we recall from our lesson on destructors, if I have an animal and a bird, and let's say I make a new bird, right? Let's actually, sorry, this should be dynamic. So I've made a new bird, it's on the heap. I'm going to call delete on it at some point. When I call delete, if you recall from constructors and destructors, it calls the bird destructor first, and then it calls the animal destructor. Now, if I'm using, or if I'm not using virtual destructors, let's say I have a animal pointer here. All right, so now my handle is an animal handle, and I'm using static binding on my destructor. So what's going to happen is it's actually not going to call the bird destructor. It's going to go straight to the animal destructor. It's going to skip the bird destructor, which is hugely, it can be a very big problem. Maybe not if you don't have any dynamic memory in bird, or you don't have any open files or anything like that. But if you do, then this is going to be a big problem. So virtual destructors, if you're using polymorphism at all, well, actually, if you're going to call delete on a base class handle for a derived class object, you should make the destructors virtual always. So yeah, let's take a look. This next example. Okay, so I have, yes, I have my virtual speak function now, my animal class, and now I have a destructor that simply declares that my animal is being destroyed. And then my bird has its own destructor where it declares that it's being destroyed, and the chicken has a destructor, and the cat. And now I'm going to make a bunch of animals. These all have the proper handles initially, but they're dynamic. So I'm going to call delete on them at some point. And then I'm going to make a vector of animal pointers. All right, so as mentioned, you're free to use vector in your assignment 3. So some of this, if you're not familiar with it, then we're going to be looking at a few examples with vectors coming up. But of course, vector has this push back function where I can push these things on the back of my vector. These are all animal pointers, and technically, I mean, my chicken pointer is not an animal pointer, but if I push it on, it gets converted to an animal pointer, right? So I can store these addresses as animal pointers. So every one of these, once I push it onto my vector, becomes an animal handle. Okay, so now I have a vector full of animals, and I'm going to call speak on all of them. My speak is virtual, so it's going to correctly, they're all going to make the noises that they should. And then we're going to delete them at the end. We're deleting them directly here at first using the proper handles, but we will take a look at what happens if we try and delete using the vector. What is this, P3? Okay, so the animal owl speaks, Tweety bird tweet tweets, chicken says cluck cluck, the cat says meow. When I slaughter them, I delete the animal. Well, the animal only has the animal destructor. When I delete the bird here, well, you can see that first the bird destructor is called, then the animal destructor, and my chicken has 3 layers in the hierarchy. So first the chicken is destroyed, then the bird part is destroyed, then the animal part is destroyed. So using the proper handles, the proper destructor is called, but this is just static binding, and this is pretty awkward if I had like 100 or 1,000,000 animals. I don't want to do it this way. What I want to do is I want to destroy everything using my vector. Okay, so I loop up to vector.size. Instead of calling speak, I'm going to call delete. And I'm using the @ because it's memory safe, although I would feel pretty confident about using the subscript operator as well. Okay, so then. Okay, so now my barnyard slaughter is using the animal handles. So yeah, before we had, each of the layers got destroyed, but now because I'm only using static binding on my destructor, only the animal part of each animal is getting destroyed, which may not be a problem, but probably is a good idea to not do this in general. All right, so questions so far? Yeah. In the assignment? No. You can use it. So the queue is specifically for holding orders. Oh yeah, maybe I'll talk a little bit about the, how much time we got? Maybe I'll talk a little bit about the assignment before we go, just so that, I know that's the common complaint. Anyway, to answer your question, no. So the Pierre's Poutine or whatever, it stores all the franchises and all the drivers, and you decide how you want to store them. You can use whatever you want, vector, or you can use a primitive array, or you can use an array class from a previous assignment. Yep. Right. Okay. So, well, what's happening here is you can remove them, and they will be their underlying object, right? So I would have to, the pointers, however, are now animal pointers. So that's the only thing that's changed. But my animals, right, I have, let's say, a cat. These are all on the heap. I have a bird. And then I have a vector, which basically has an array behind it. And these have animal pointers. So what the conversion that is happening here is that when I push, so I have my cat pointer, Lily, when I push it onto the vector, it gets converted to an animal pointer. Same address, but now it has a type of animal. The type of thing that it points to is animal. So I can, I can grab this pointer, I can cast it to a bird pointer, and then now I have a bird pointer pointing to bird. So yeah, nothing. The only thing that changes is the pointer. Yeah. Other questions? Yeah. Would you have an example? No. Just, I mean, if it takes 5 minutes to run your code, that's a problem. But yeah, it's just an opportunity for you to make some design decisions, and whatever you want to do, go for it. Yeah. Yes. If I try to push something that is of a different type onto the vector, so I can say vec dot pushback 1. All right. So yeah, it doesn't like that. And if I, yeah, if I had a different type of object, it would do the same thing. Yeah. Other questions? Okay. All right. So now yeah, we have our barnyard slaughter. We're, we got to eat at some point. But we have a very inefficient way of, and if I had like an egg, so I think I have a note here. Where is that? Am I in the right one? Yeah, I'm in the right one. Anyway, if I had an egg object, a dynamically allocated egg in my chicken, let's say, and in my destructor, I deleted it. Well, if I use static binding on my destructor, then I have a big problem, because that's not going to get called. I'm going to have a memory leak. So the same as with my speak function, I go to the base class, I add virtual to the destructor, and then, Now when everything's being destroyed, let's let's add a little formatting here. Okay, so my animal owl has only the animal part destroyed. Tweety bird has the bird and the animal part. The chicken has the chicken, bird, and animal, and the cat has the cat and animal. So now, using virtual destructors, I can make a bunch of dynamic objects. I can push them onto a data structure that has a common base handle, in this case, animal, and then I can use them however I want, right? So I speak here, I delete them at the end, and everything just happens the way it should. All of the proper functions are called, and they are deleted correctly. Yeah, all right, questions? All right, how are we doing for time? 3:41. Okay. Let's see what's next. Maybe I will talk about, let's talk a little bit about the assignment. I just want to give you an overview of what the assignment is and what it's doing, because, yeah, I guess a complaint that I get is that they read the specification. You can read the specification, you can follow it, you can build the thing, but you don't really know the big picture until you get to the end. So I'm going to try and give you the big picture, and I might give you a few hints for your UML diagram as well. All right, so we have, incidentally, your controller and your view class. You don't have to include them in the UML. That's fine. So we can start with Pierre's is the base class. So it's some sort of franchise. I'm terrible with being creative here. So just what Pierre's Poutine is a franchise, and it has multiple locations across the city, and it delivers food, but they have their own delivery drivers. So what we're writing is an application so that to manage all of this, right, in real time. It's fake, obviously, but so the sort of control class, kind of the control class of the thing is the Pierre's class. And this contains a bunch of franchises and drivers. So franchises and drivers have a base class of entity, right? And entity is just basically, well, they're both part of the Pierre's, I guess, they're all employees of Pierre's, let's say. So it's just something that is associated with this franchise. In this case, I have two derived classes. I have driver. So this is a Pierre's Poutine driver. And I have a franchise. Okay, so then the entity has all of the common, like the ID and the queue of orders, right? So both drivers and franchises, when I call in an order, it gets forwarded to the closest franchise location. And then when a franchise has enough orders, I call the driver comes and picks them up. Yeah. Right. Yeah, exactly. So I do not want to see queue in your UML diagram, right? So that is an implementation detail. It has nothing to do with sort of the higher level object-oriented, the way we're organizing it, because here it might be a queue, but this is supposed to be language independent. So maybe in Java, it's something different, right? So yeah, do not put that. We represent that. I have a bunch of orders. Well, Pierre's has a bunch of drivers. So we could say 0 to many. And it's going to be stored in some data structure, maybe a vector, or maybe a linked list if you want. You could even, I don't know, you could use whatever you want. But you're not going to represent it here. You're going to do something like this. So this means, and try and organize your classes a little better so it's not that messy, but this means Pierre's has 0 to many drivers and 0 to many franchises across the city. All right, and then basically, and there's going to be orders, right? So each driver has a queue of orders that they're delivering, and each franchise has a queue of orders that it's ready for the driver to pick up. So the driver comes, picks up orders, starts delivering them around the city. Yeah.
Here's one point for that, right?
I would point to entity if I stored an entity. So we're talking about polymorphism right now, but we're not using it yet. So in assignment 3, it's just inheritance. Well, if I stored a vector of entities, then I would point to entity. But if I store a vector of drivers, then I point to drivers. And if I store a vector, so yeah, point to whatever it is you're storing. So in this case, yeah, if I'm storing a vector of drivers and a vector of franchises and not an entity to be found, it's just a simple base class. I'm not using polymorphism, then I don't point to it. Yeah. Other questions? All right, and yeah, so each drivers and franchises have orders, and yeah, that's basically the size of it. There's a few implementation details other than that, but it should be pretty straightforward. Questions? Yeah. Yeah, no. So polymorphism, that's for assignment 4. This is just straight up inheritance, and we're using inheritance because, I got to pay my drivers and I got to pay my franchise owners, so they have some sort of record in peers. Yeah. I want to say yes. I almost certainly, yeah, probably, yeah, yeah. Yes. Yeah, I guess somebody else brought it up. So yeah, I don't want you really storing, unless you could do it really efficiently. But if you're wasting a lot of memory, then you might lose a couple marks, right? So yeah, it should be on the heap. If I add a franchise, I should not be storing like a million franchises just in case I need them. I should, make them as I need them. And same with the drivers. All right, other questions? Okay, so we got about 5 minutes left. Where did we leave off here? Oh, null pointer and null. Yeah, so you can use null pointer or null, I don't care, but there's not much of a difference in terms of, you're not going to run into any problems whether you use null or null pointer. But null pointer is, in some sense, better to use because null can accidentally be cast into an integer. So, there are circumstances where I maybe, for whatever reason, I try and pass in a pointer as an integer argument. Well, let's say I have an overloaded function, then it's not a danger because the compiler will catch it, but you'll get a compiler error. So null can be cast to a integer, a 0, but null pointer is a type null pointer, which can't be cast to an integer. That's basically, but for our purposes, either's fine. But this is, null pointer is sort of what you should be using. All right. Okay, so let's see, where did we leave off here? All right, so we have our destructors should all be virtual. And now, yeah, we can quickly do this and then that should be it. So if I have a non-virtual pointer, of course, I have base class to base class to derived class. I still have a base class function call. Derived class to base class, I get an error. Derived class to derived class, I call a derived class function. If I have a virtual pointer, well, I still have a base class. I still get an error. And here is still a derived class, but then there's this special, the base class pointer to the derived class object is the special polymorphism, thing that's going to set us up so that we can do design patterns and higher level stuff. Yeah. All right, so that brings us to abstract classes. So we've seen virtual functions, but we can also have in C++ what are known as pure virtual functions. And this is, so in Java, of course, they're called abstract classes. They're called abstract classes here. Basically, it's a function that has no implementation. I just say, I give you the function signature. I say, if you are going to inherit from this class, then you have to implement this function, or else you're going to be, you're going to be abstract as well. So in your UML diagrams, if you have an abstract class, you use italics. I don't believe we have, we don't have those for assignment 3. An abstract class cannot be directly instantiated. So if my animal is an abstract class, I can have an animal pointer, but I can't have an animal object. So it's typically used as a base class. And in some sense, we can, Java does have abstract classes. Java also has interfaces. And using pure virtual functions in C++, we can make what is essentially an interface, right? We can just specify a bunch of, bodiless functions. I just specify some behavior and say, you have to implement this behavior, right? But in C++, the difference is there's no difference between an abstract class and an interface. So we can implement both of them, but they're the same thing in C++. So how I would declare a pure virtual function is I set it equal to 0. All right, I would have to look up exactly what this is, but I believe, so a function basically has a value that is the address of that function. If I set it to 0, I'm telling the compiler, well, there's no implementation, right? So this is essentially like a null. So if I, in my .h file, if I make a pure virtual function, then in my .cc file, I should not have an implementation. And if you do, it'll cause problems. Yeah. I'm sorry, what, right, it's implemented in the derived classes. So we'll see, maybe we're probably not going to get to it today, but next class, when we look at example 4, we'll see that, yeah, I'm going to have a base class. Basically, my animal class, I will have, some pure virtual functions. So now I'm saying, well, these animals have this behavior, right? Because it doesn't make sense for an animal to speak. What does that mean? I don't know. It's too general to be useful. So I'm going to make that an abstract function. And then I'm going to let the derived classes decide how they should speak. So a cat's going to meow, a dog will bark, but animals by themselves, they don't make there's no definitive animal sound. Yeah. Oh yeah, because it was made 40 years ago. I mean, that's a lot of this there's a lot of legacy stuff in C++, yeah, because they made the best decisions at the time, but they didn't realize where we would be. I mean, it's still, as archaic as it is, C++ is still extremely useful, right? In real time, and like AAA video games, if you're making those, you're using C++. They haven't replaced it yet anyway. Maybe there's something in the pipe, but so yeah, it is still very extremely useful, even though we have to put up with all this stuff that yeah, was decided 40 years ago. Yes, if there's no return type, you can just do void. If you do bool, it's fine. It should be fine. Yeah. The table. This one was just the combination of underlying class and handle and what the result is in terms of a function call. Right. So this is, I have a non-virtual pointer of a base class type to a base class object, I get a base class function call. And then, yeah, same here. This is just basically the difference between static binding and dynamic binding. Is there another question? Yeah. Yeah. At least as far as I'll tentatively say yes, but we'll test it out next time. Yeah, I'm almost certain it can be, because I'm pretty sure I've done it in, yeah. All right. So that's it for today. Yeah, I'll see you guys on Wednesday.